All right, Passerians, this video is 2.4c, the chain rule. It's our third day, or maybe our fifth day of doing the chain rule. We've been doing it for a while. You're going to write the date up here, just like that. And the key idea today is that logs can be our friends. And not a lot of people believe me when I say that, but in calculus, it's true. This says remember pre-calc. Hopefully, you do remember pre-calc. There's some log properties we got to deal with. First one is basically when you have a product inside of a log, it becomes addition outside of the log. And that can be with any base. I put a b there because it can be log base 2, it could be log base 10. That's that little guy that's underneath. But if it's ln, it's log base e, and that's usually what we're going to deal with. If you have division inside of the logarithm, that's a division sign, then that becomes subtraction outside of the logarithm. And if you have a power, a log with a power, so it's something to a power, that's going to come in front, but this is not the power rule. This is not the power rule. Okay, let's put an exclamation point over here just for fun. Okay, good. So it's not the power rule. It looks like the power rule, but what's in green is not the power rule. It's actually a pre-calculus logarithm property that you should have learned. The last one is when you have log of two things here, when you have log of some base over x, log of some base of x, which is log base b of x here, it can also be written as ln of x over ln of b. You won't use this one as much. I would star these three. These are your main three that you need to know, for sure. Not to say that the fourth one is like off limits, but you're going to see the other ones at least twice as much. So a couple of other important things, other things, especially pertaining to natural log. If you have e to the ln of x, the e and the ln kind of cancel to give you just x. E to the ln of x is just x. If you have this right here, e to the ln of a times x, that's a little weird. So what I did was I rewrote this as this. You think about that, I did it by exponent properties. A power of a power, like with an exponent to a power is multiplication. So this right here, because we're raising it to a power, it's multiplication here. So I rewrote it like that, and then I canceled out the e and the ln on my next step. So kind of here, I canceled out my e and my ln. I had just a, so this is that, a. So it's just a to the x. So this is the work. The green is the work. The red is the rule. So the question basically came, can we reverse the process? So like, could we use the same exact property in reverse? Like, let's say the green one right here. This is kind of specific to what we were talking about. Fair question. Can you take this and turn it into this? Well, of course. Sure, you can, because they're equal, so you can go either direction. So keep in mind that if you had something like that in front of the log or something, you could put it into the power if you wanted to. But generally, you want to simplify, so you want to go from the left side to the right side here with this blue, red, green arrow, etc. So here's an example. We want to differentiate this problem, okay? And we can do this. We can do this right now. We don't have to use any log properties. But it's going to be better if we do, because I'm not going to write, once I use color, that's calculus, okay? So everything in black is not calculus. This is not going to be calculus. I'm just going to write f of x equals ln of whatever to the 1/2. You see what I'm saying? It's this to the 1/2, because the square root is a 1/2 power. And then without using any calculus, I could use log properties. The log properties tell us that this would be 1/2 ln of x plus 1. So log properties got us here. Now we could probably derive. So I'm going to derive this problem right here, and I'm going to just underneath it, I'll use color now, y prime equals, I'm deriving this right here. So I'm working on that guy. Well, the 1/2 just stays. And ln, you've probably learned a trick about that. You write 1 over whatever's on the inside, and you multiply by the derivative of what's on the inside. When I say inside, I mean x plus 1. But really what you can do is just do the derivative of that red thing, 1, because the derivative of x plus 1 is 1, over x plus 1. So that's it. The 2 can distribute in. or it can just be where it is. So it's y prime equals 1 over 2x plus 2 is probably your best, most simplified version. So hopefully that's making some sense, and we'll take it to a way more difficult problem now. All right, so just taking a tiny step forward, you know what I mean? Just taking a tiny step forward here. Let's try this one. How exciting. We have a whole bunch of stuff divided by a whole bunch of stuff. So I'm not going to use any calculus yet. I'm simply going to use this to write f of x again. So my first log property tells me I can do log, or ln in this case, of the whole entire top minus log of the whole entire bottom. Easy peasy. Okay, great. That's our first log property. So take a look at that, see how that's looking to you. Okay, we broke it in half. We made the problem half as bad as it used to be. Now let's break into each of those pieces quickly. So going through this first piece, let's forget about where that came from for now. You can always rewind if you need to. Let's just work on this guy right now. A lot going on here. I'm going to see multiplication first, so I'm going to change it into ln of x plus ln of x squared plus 1 all squared. I'm going very step by step here. Eventually it'd be nice. Oh, I shouldn't have even used color. That was cheating. I got to change that over now because I violated the rules. We're going to the next one, and we're going step by step here. I could have simplified this a little faster, but for the most part, I kind of want to show you where everything's coming from as slowly as possible. We still haven't done any calculus. We haven't derived anything. Everything here is kind of from pre-calc. Minus, I see that this has the, this is a 1/2 power. So if you don't mind, we'll just kind of erase this, and we'll make it a 1/2 power. There shouldn't be that little sign there. That's not good. So we have a 1/2 power of this. And so couldn't that 1/2 come in front of the ln? And then you have 2x cubed minus 1. Okay, we've gotten to a much better problem. 3 smaller, nicer looking problems, neither of which is really nice in and of itself. But actually our first one we could honestly pretty much derive. So I'm going to leave that the way it is. I still have not derived anything, by the way. I have not used the power rule. Now I'm bringing down this power, 2 ln of x squared plus 1 minus 1/2 ln of 2x cubed minus 1. Okay, I know, it looks bad. It looks bad. But its bark is worse than its bite. We just have to take the derivative of whatever's inside the ln and put it over exactly what's inside of the ln 3 different times. So if it makes you feel better, we'll build some walls here, okay? Build some walls here. Not supposedly a political reference, but some of you might take it that way, yeah. So now we have the walls built. That's great. The derivative, now we're actually doing calculus. I'm going to use color. F prime of x is equal to, well, ln of x derivative is 1 over x. It's kind of memorized. In other words, the derivative of x is 1, so that's that, the derivative, and then the original is x. Shortcut, if you like. Okay, new color. We have this minus 2, right? So minus 2. And I'm going to make a fraction. And I have x squared plus 1, so that's going to be 2x, the derivative of this. And then I'm going to leave it completely alone on the bottom. And we'll simplify this later. That's a multiply. Okay. So let's look at that. Say that again.
Should be a plus.
A plus where? Here? Oh, perfect. Thank you. So the wall blocked out, the comment came actually, that the wall was blocking out the plus sign. But now we've realized our mistake. Let's just move that wall a little bit over so it's a little less confusing. Good. Okay, so now we're on to the third one, and we'll use another color. And we'll take this guy, which is this time it's a minus 1/2, I believe. And I've got to, if you want to use parentheses, I don't know what your preference is. I don't really use parentheses usually. I just put the 2 in front, like so. But if you want to use parentheses, I take the derivative of this, and I put it over itself. So, whoops, sorry, that's supposed to be, dang. Okay, so double mistake here. Okay. So I put the original on the bottom, right? And then I derive what I just wrote down, which is 6x squared. So that's it. We've now done all of the calculus necessary for this. So we're going to keep going, simplify this a tiny bit. So f prime of x is equal to, f prime of x is equal to, let's get these out of the way if we can. It's equal to, I guess, 1 over x plus 4x over x squared plus 1 minus 6x squared over 4x cubed minus 2. And that's it. So that's kind of how you're going to use log properties to make something that was really bad into something that's just regular bad. So at that point, that's your answer. We're definitely not going to find a common denominator in this situation. So this is a situation where people ask on how much to simplify. Don't find a common denominator here. Well, yeah, I mean, of course, you should probably simplify this by putting the 2 in the top right here. I think that's a pretty reasonable thing to do. But it's not necessary for you to find a common denominator for this final answer. That's a good final answer. It's ready to go. There might be times where you need a common denominator a chapter from now, and we'll have that discussion when it comes, but for now, let's not worry about it, really. So this is just extra space for the work, because I figured that was a lot of work, but I don't know if you need it. And I'm just trying to restate everything we're talking about. And lastly, this is kind of... Actually, this shouldn't even say just to restate, because I don't think I've ever told you this. So let's call this how do you derive something that's not an ln? So the idea is that if you're taking an exponential, like let's say you have e to the x and you derive it, it's e to the x. Very simple. But if you're deriving something that is not e to the x, what you need to do is rewrite it and then multiply by the ln of the base. What's the key here is finding what the base is of each of these. So the base of this is an a, and that's kind of what we want to have. So I know that's a little hard to see here, but how would we derive this blue one? We'd take 2 to the x, and we'd rewrite it. The derivative of e to the x is e to the x. The derivative of 2 to the x is 2 to the x, but there's a catch. The catch is, we have to multiply by what? ln of, can you see it above? ln of what? 2. Yeah. So that's the catch. The derivative of e to the x is e to the x, and there's nothing else, because you multiply by ln of e. But the derivative of 2 to the x is 2 to the x, and you multiply by ln of 2. So it's one extra step. How about the derivative of 4 to the 3x squared? Well, we know that we're going to need to take the derivative of 4 to the 3x squared, and we're going to rewrite it. 4 to the 3x squared, perfect, times, do we have a chain rule this time? Do we have a chain rule? Yeah, what's going to be multiplied here? We have to multiply by what? 6x. Is everybody seeing where the 6x comes from? 6x is this derived. And what did I say the catch was when it's not an e to the x? It's a 4 to the x or something. I have to multiply by ln of 4. So I have to multiply by ln of 4. Let's keep our focus off of simplifying that right now. If you can just write it like that for now. Those are multiply signs, by the way, not minus signs, so just to clarify that. So that's the first type. That's a log of a different base. And next, I don't know if I said this in this video that we would do that 24 hours from now, about 5 minutes ago, but here we are. So let's go down and talk about the log of a different base. Log base 7 of x. So it still has a similar trick. If you look inside the little box with the QR code, you might be able to figure out the trick before I say it. But we're going to do this just like we would normally. If it was ln of x, we would write 1 over x. So that's what we're going to write, 1 over x. But there's a trick. Instead of multiplying by ln of the base, which we did up above, we're going to divide by ln of the base, which is 7 in this case. And that's it. That's all you have to remember. So if it's not an e, if it's not log base e, which is also aka ln, this is pretty important, by the way, if this seems weird to you. This is the same as ln of x. These are the same. You might want to write that down if you don't know that for sure. That's pretty important. I just assume you know that for sure. So log base e of x is ln of x. So if it's anything other than ln of x or log base e of x, you have to divide by ln of whatever the base is. The base is the little guy. Lastly, we are going to talk about this one, log base 10. And with that one, we just take the... We'll pause. Okay, so the bell rang, but I'm probably not editing that out, so we'll just continue on. So I just had a question. A question came about this right here, 2 to the x. See this 2 to the x? It's on your paper, so for you, you're probably fine. I'm just going to get a little more space here and talk about that 2 to the x for a second. The question came, what's the deal? Why can't we use the power rule? Well, it's exactly opposite of what we want. We cannot do this, okay? So we cannot do x 2 to the x minus 1. This is definitely not allowed. So this is a no-go, okay? You can't use the power rule on a number to a variable. You can use the power on a variable to a number. So if they were switched, we'd be okay. So the question came, can we use the power rule? The answer is no, only on a variable raised to a constant power. That's the power rule stipulation. So lastly, we're on this last problem. We have log base 10 of 4x squared. Well, the trick is to take the derivative of the inside, the derivative of that, which is 8x, and put it over what it was, 4x squared. Okay, so that's normally what we do. We call it a day then. And the chain rule is kind of encompassed in that little shortcut. But we're not done in this case because there's a catch. And I said the catch is that you have to divide by ln of the base. So we have to divide by ln of 10. You could do divided by ln of 10, but I just put it in the denominator, and now it's divided. So that's kind of like where we need to be with this video. Remember, you can't use the power rule. Hopefully this is making some sense to you. And that's it. So we're going to stop there, and I will see you in the next video. Peace.